We are going to do question 5 from the 2011 exam. Now, for this question, we just need to solve the simplex algorithm and determine the final tableau for this LP problem. We do not have to write down the solution at the end. We just need to clearly show the entries that we will pivot on. So we will follow the usual simplex method. And first we need to find the biggest negative entry in the Z row. This is -3 in this case. And then we need to look at the smallest positive ratio from these two. So we have 3/4 and 2/3. So the smallest positive ratio is 2/3. Hence, that means that we're going to pivot on 3. So now we need to turn that 3 into 1. So we will divide the whole row by 3, and we're going to have 1, -1, 0, 1/3, and 2/3. And now since x1 will be the entering basic variable, we will have x1 here, and s1 stays the same. It will still be the basic variable for this row. Now, in order to make every other entry in this column 0, we need to follow some calculations. We need to take S1, the row S1 over here, and subtract 4 times the x1 row over here. This is the x1. So by doing that, we will have 4 minus 4, 0, 2 plus 4 is equal to 6. 1, well, minus 4 times 0 is just 1. And then we have 0 minus 4 times a third is -4/3. And 3 minus 4 times 2/3 is just 1/3. Now the next thing is we continue to make -3 in the Z row into 0. So what we can do here is, without using the x1 row, we can just add these two rows together. So that will be Z plus S2, and it will give us 3 minus 3, the 0 that we want. -3 minus 2 is -5. Then we have 0, 1, and 2. Now, again, we need to find the entry that we will pivot on next. So we have -5 as the only negative entry in the Z row. And since we have a negative number in this column, it means that we are going to pivot on 6 as the only positive ratio. Now, in order to turn 6 into 1, we need to divide the whole row by 6. So we will have 0, 1, 1 over 6, minus 2 over 9, and 1 on 18. And since this is the entry that we will pivot on, then x2 is the entering basic variable. And then we will have x1 here as before. And what we need to do here is we need to take x1 and add to it the new x2 row, since we have -1 and 1 here, and that will give us the 0 that we want. So we will have 1, 0, 1 on 6, 1 over 9, and 13 over 18. Now again, we need to turn -5 into a 0. So at this case, we take Z, and we will add to it 5 times the new x2 row, this one over here. So we will have 0, 0, 5 on 6, -1 over 9, and 41 over 18. we can see that we still have a negative entry in the Z row. So that means we need to perform the simplex algorithm once more. So since this is the negative entry and we're looking for the smallest positive entry, this will be the entry that we will pivot on since this is a negative number. Now, in order to make that a 1, we need to multiply the whole row by 9. And now the entering variable will be S2. So we'll have S2 here and X2 here as before. And now multiplying by 9 will give us 9, 0, 3 on 2, 1, and 13 over 2. And now, in order to have 0 everywhere else in this column, we need to take X2 and add to it 2 over 9 times S2, the new S2 that we just created. So that will give us 2, 1, a half, 0, and 3 on 2. And now the last thing is that we need to take Z, and in order to create a 0 here, we need to basically just add x1 to it. So in this case, we just take Z and add x1 to it. So the old basically row here and not the new one, because it's just easier and faster to create the 0 this way. So we will have 1, 0, 1, 0, and 3. And now this is everything that we need to do for the simplex algorithm. We pointed out each entry that we pivot on. These are the calculations that we usually do not write down on the side, but it's just easier to look at it that way for this example. So this is everything, and that is question 5.